For this question, it says design a Mealy sequence detector that takes one input X and outputs one output Z. Z is 1 if and only if the last sequence is 1, 1, 1, 1. So when our sequence reaches 1, 1, 1, 1, basically that's saying our Z equals 1. So your first step is to do a state table, and you're going to have 4 states for this because there's 4 inputs. So A, B, C, and D. So when A is 1, it's going to go to B, right? Because you're going to go to your next state in the sequence, but your output is still 0 because we need 4 ones for our output to be 1. So now B goes to C when the input is 0, but the output is, or when the input is 1, but the output is still 0. And then now C goes to D when the input is 1, but the output still remains 0 because we still need 4 ones to make our Z to be 1. So this here is our Z, and that's our X. That's how you can think about these. So now D, when D is 1, the input is 1 at D, you can either go to a next state E, and the output will be 1, because we reached our 4 ones. So 1, 2, 3, 4, that's our 4 ones. Or you could just keep it simple and stay at D, and then when the X, the input here is 1, your output will be 1. So now when you do our zeros, when X equals 0. So at A, when X equals 0, you're going to go back to A again, because our sequence is broken. So now at B right now I have 1 here, right? If I put a 0, my sequence here is broken. It doesn't match all ones, so I need to go back to A. So it's going to be an input of 0 and the output of 0. Now at C, again, we have 1, 1. We broke our sequence because if we put a 0 here, this 1, 0 doesn't match any of these. So we have to go all the way back to A again. So it's going to be 0 with an output of 0. And then at D, if we have an input of 0, we're going to go back to A again because it broke our sequence, and the output would be 0 as well. So now when we do our state table, we're going to have our present state, our next state, and our output. But we know that our output Z is going to have two columns, X equals 0, X equals 1, because it's a Mealy. So now my present state, I'm just going to fill it with my states. So I have A, B, C, and D. So A, B, C, and D. So now A is how we're going to read the diagram we just drew. When X is 0, it's right here, right? When X is 0, my output is 0. So X is 0, it goes to A again, goes to itself, and my output here is going to be a 0. So I'm going to put A, when X is 0, goes to A, the output is 0. So now when X equals 1, the output is 0, and it goes to B. So when X is 1, it goes to B, and the output is 0. Now for B, let's just color code these. Now for B, when X is 0, it's right here, the output is 0. When X is 1, the output is also 0. So I'm going to put 0, 0 here. And then B goes to A, right here. B goes to A when X is 0, and B goes to C when X is 1. So B goes to A when X is 0, B goes to C when X is 1. So now quickly we can look and we can see that, okay, everything goes to A when X is 0, and the output is going to be 0. And now when X equals 1, they just go to, so C goes to D, and D goes to itself. And then the output here is also 0, and then D, the output is 1. This is the only time we have the output is 1, is when D goes to itself, because that's when we get our 4, 1, 1, 1, 1. Okay, so now we have to convert this to binary before we can get any equations for our K-map. So here I have my present state, this is Q1, Q2, and then my next state when X equals 0, X equals 1, this is D1, D2. The reason why I do D1, D2, so this is So here they ask you to use a state assignment and state excitation to draw your logic diagram. The best way to do it is to use a D flip-flop, because for D flip-flop, when D is 0 and a 1, your Q plus is 0 and a 1, so it doesn't change, right? So your state assignment table and your state excitation table will be the exact same thing for a D flip-flop. So I'm just gonna put like, so normally you would have like Q1 plus and Q2 plus. I'm just gonna cross these out and put D1 and D2. Now I have, this is my state table. Here's your state assignment table. And now it's also my state excitation table for my D flip-flop only. I don't have to convert anything. Okay, so now going back to here. So my Z has x equals 0, x equals 1. My Z never changes. So I'm just going to fill that out first. So 0, 0, 0, 0, 0, 0, 0, 1. And then, so for A, I'm just going to put this as 0, 0, 0, 1, 1, 0, 1, 1. You can just pick whatever you want. I'm going to do that. I'm just going to put them in order. So A here is 0, 0, 0, 1, 1, 0, 1, 1. So the way I fill this out, this A here corresponds to this here. And then this B corresponds to here. So you're just moving them over. So A is 0, 0, 0, 0, 0, 0, 0, 0. And then B is 0, 1. C is 1, 0. D is 1, 1. And then D is 1, 1 again. So this column, here, let's just move this. Okay, so this column here is for D1 when x is 0, and this is D1 when x is 1. And then this one right here, D2 when x is 0, and this is D2 when x is 1. So when you go to fill out your K-map, that's how you're going to look at them. So let's draw our K-maps. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. This is going to be for Q1, Q2, and X. So I'm going to paste this 3 times because I have 2 D flip-flop equations I need to look for, and then I have my output equation I need to find as well. So trying to get these on the same page. There we go. Okay, so for Q1, so this is, we're going to have D1 right here equals, this is D2 equals, and then this is Z equals. So for D1, we look at the pink, or the green. So D1, we have when x equals 0, so here, when x equals 0 is right here, so it's this whole row. There's, all we want is our midterms. So that we can see that we have zeros. There's no ones in this column, right? So we know that all these are going to be zeros. You don't really fill out zeros in a K-map. But then now if we look at when x equals 1, so when x equals 1, that's this row. That corresponds to this column right here. When D1, when x equals 1. So I can see that I have x equals 1 here, here, and here. So that's where I'm going to apply in my K-map. So I have my present state, so at 0, 1 I have a 1. And then at 1, 0, and at 1, 1. That's it. That's all you have to do. So now, go down and I go do my D2. So D2 when x equals 0, they're all zeros, right? That's this column right here. We have no midterms. And now if I look at when x equals 1, I do have midterms. I have midterms at 0, 0, at 1, 0, and 1, 1. So D2 at 0, 0. This is actually when x equals 1. So 0, 0, at 1, 0, and 1, 1, I have midterms. And then for Z, I only have one min-term, and that's at 1, 1. So I'm just going to put it at 1, 1. Now I go and I group them. If you can have overlapping between two different K-maps, like, try to group them in that way. So what I mean by that is if you look here and here, and here and here, they overlap. So when I go to draw my gates, I can use less gates when I go to draw them. So those two overlap, and then just you can group these, and then this is a separate grouping, and then this just groups by itself. So my equations end up being, for D1 I have Q2 X, and then Q1 doesn't change, and then I have X again. And then for D2 I have Q2 naught and X plus Q1 X. See, there's overlapping here and here. And then for Z I just have that one term, so it's going to be Q1, Q2, and X. Alright, so now that I have my equations, I can do my actual logic diagram. I'm gonna copy and paste these here. So for D2 I have this equation, and then here's my Z equation. Alright, I want to just move these down here so I can have a fresh new page. So I have one flip-flop for D1 and another one for D2. Oops. Alright. So I have D1 here, I have D2. If you want to include your clock, you can. Just going to assume positive edge. So write CLK here. This is Q1, this is Q1 naught, this is Q2, and then Q2 naught. Okay. So let's do our D1 first. So for D1, actually I should include my X as well. So X I'm just going to do like this. And then when it's knotted, I'm just going to have it like that. That's how I represent that. So then now for D1 I have Q2X, so Q2 is here. So I'm going to draw my gate. This is for Q2. And then my X. Should have drawn that higher, but it's okay. And then I have Q1 and X. So Q1 and then X. And then now for D2, I know that I have overlapping with D1 here. So let me, before I forget, I need to order these together. That goes into D1. And then now I have D2. Draw it like this. So for D2 I have Q2 naught. And I have X. And then I have Q1. Yeah, I'm not drawing these perfectly. I'll put in the description, I'll put a link to the actual solution to this question. It'll be a lot neater. And then I have Q1 going into it, and that's X. Okay. And these just go together into this gate for D2. Now for Z, you're going to draw it here. And you draw AND gate. And then you have Q1 again. You have Q2. And you have X. And then X will just come all the way to here. And then that's Z.